All right, so today we're going to learn a little bit about some trigonometry and I believe some special right triangles. So we're going to start off by using proportional relationships from section 12.3. So basically, whenever we're looking at proportions, we're going to be comparing the same heights and distances of each side of a triangle. Remember again that the order of how they write the question matters. Almost all of these questions are going to be word problems. Some of them you'll be given drawings, others you'll need to draw yourself. Okay? So, Sid is 72 inches tall. So, obviously, this is his height. We know that people stand like this. So, if I was drawing this from scratch, I'm going to read a little bit of my problem and write it to the side. So, I would draw Sid and I would also include the 72 inches. To measure a flagpole, Sid stands near the flagpole. So now I would draw the flagpole. They're two separate things, right? Sid's friend Miranda measures the lengths of Sid's shadow and the flagpole's shadow. So the other thing that we're looking at is their shadow. Miranda is simply put in there as a distractor. She has nothing to do with the mathematics behind this question. Find the height h of the flagpole. Now, obviously, they didn't give us these numbers, but this is their shadow on the bottom here. If they had given us the shadows, then we would just simply draw them in. So the idea of proportions, when you're talking about comparing two things, in this case, this does create a right triangle. And when you're talking about shadows and things like that, this is a very popular question all the way up through calculus. So what you're going to do, and there's several ways to write this and get it correct. You just have to be consistent. So let's say, for example, I want to compare 72, which was the height of this triangle, to the height of the flagpole. And I just have randomly selected to start with 72. But what's important is that I decided to put the smaller triangle on top and the bigger triangle on bottom. However I decide to write it, I have to stay consistent. Now, you may have decided to put H on top. If you did, then I would need to make sure that when I write my next proportion that the bigger triangle is what I'm going to start with on top as well. So because we've started with the small triangle on top, I'm now going to compare the other two numbers that I have of this triangle, which happens to be the shadows. And I know, again, since I used the small triangle for the top, I'm going to use the small triangle for the top for my second proportion. And like I said, I'm comparing the shadows at this point. So the shadow of the larger triangle is 128. Every problem that you do for this section should look like this. So if you remember correctly, when you have two fractions that are equal to each other, to solve for a variable, you're going to cross multiply. So I'm going to cross multiply h times 48 and then 72 times 128. And then I'm going to divide both sides by 48. You may decide to go ahead and multiply 72 times 128 and then divide by 48. Go ahead and do that now. So I'm going to get 192. I'm going to reread the question, and it says find h, the height h of the flagpole. Let's make sure, since my question gave me the units in inches, then I'm going to write my answer in inches as well. So the main idea is that you're going to make sure that however you decide to set up your proportion, that you're staying consistent. Let's go ahead and try another one. In this case, our triangles are possibly flipped and turned, and maybe the sides that are congruent are a little bit harder to see. So, a hiker wants to find the distance, d, across a canyon. She locates points as described. All right, so what we're going to do is we are going to be comparing the two information to find the distance here. So let's say, for example, I start with this triangle here. In this case, this is basically my D. So let's say 327, that's going to be my height, right? My height of the other item is going to be D. So because I have started with this triangle first, then the other piece of information that I have is 600. I have to start with this triangle again. And then on the other side, the piece of information that I have is 400. Make sure that you compare the same items. I know that D is talking about the height of the triangle, so that's why I made sure to choose this piece right here. And then 400 is the base for both of these triangles. So this was comparing the height, this was comparing the base. And we decided to go with the WVZ triangle on top and XYZ on bottom. All right, in order again to solve for these types of triangles, we're going to cross multiply. And on the other side, I'd have 327 times 400. I'm going to go ahead and multiply this first, just in case I lost you on the last question. So I have 600D equals 130,800. And then obviously, in order to solve for D, I need to divide by 600 on both sides. So D is going to equal 218. And then because we're working with real world problems, it does have units of feet. So make sure you add that on there. All right, your guys' turn. And your homework for this section is given, only numbers 1 through 13. Don't forget to use the collaboration page.